All right, hey, how you doing today? My name is Ben Schmaus. I'm a software engineer out of Ecosystem Engineering at Red Hat. I'm actually based here out of Minneapolis, so anything that we talk about today, if you're interested in talking about it in the future, we can certainly do other conversations around it. I want to talk about hosted control planes today on OpenShift. Hosted control planes. Again, show of hands, how many people are running OpenShift today? Okay, so there's a few of us, some of them with the little, they're going to think about it. How many of you deal with concerns around your control planes taking up a lot of resources? Perfect. You're the target audience right there. All right, so let's get going. So the first thing that we need to think about is talk about OpenShift. We talk about the fact that there's concepts, these basic building blocks. There's control nodes, there's infrastructure nodes, and there are worker nodes. The worker nodes are where you're going to run your workloads. The control nodes are where all the OpenShift services run. And then your infrastructure nodes can be nodes where you actually specifically run things on there, like maybe an on-cluster image registry, or you're running, maybe you're using those for your storage nodes. I don't see the infrastructure nodes too often in the environments that I've worked with, but the control nodes and the workers, they're always there. So some of the things that we see when we talk to customers is it takes a long time to create a cluster. I don't know about you, but it usually takes me, if I'm just doing the simple 5-node bare metal, it can take anywhere from 70 to 90 minutes to get that deployment to come up. And that's a large amount of time, especially when you're talking about tearing down and building back up clusters over and over again. Another one is the question I just asked. You know, it takes a lot of compute to run my control planes, compute that might not even be used. My control plane nodes may be only 50% used at capacity. And while you could taint those nodes and potentially run workloads on them, sometimes doing that isn't necessarily the right move to make here. You may have environments where you've got production running with one version of an operator, but you need to do development work on a different version of the operator. Can't necessarily run those on the same cluster because you cannot run different versions of operators on the same OpenShift cluster. Another thing is that you may not want to have your developer admins having access to the control plane itself as well. These are all things that potentially can be solved by using hosted control planes. So what are hosted control planes? So the concept of a hosted control plane is an architectural model where you remove the control plane nodes from your clusters and put them onto what they call a management cluster. So you're going to have an OpenShift cluster that's dedicated to being the management cluster that will then run your control planes in namespaces with all the services that would normally be on those physical control nodes. So what that does is it frees up that hardware that would be used by those control nodes to be used for something else. Hosted control planes also offers you that path to a centralized management platform, so you can manage all of those hosted control planes in one single pane of glass. So why would you even consider them? I think I've already kind of hinted as to why you would. One, it supports the OpenShift topologies. Two, it's reduced infrastructure costs, faster cluster creation time, because you're no longer taking a bare metal machine and writing RCOS to the machine and then instantiating the cluster for the control plane. You're actually spawning those containers as instances on an already existing OpenShift cluster. The creation of that OpenShift cluster when it's a hosted control plane is much faster. You also can have stronger separation between your control nodes and your workloads. It also supports multi-architecture and multi-platform. So you can have hosted control planes in a variety of scenarios: AWS, bare metal, virtual machines, depends upon what you want to do for your organization. And then, of course, you get that benefit of that centralized management. So here's an example of customer environment where they've got basically 3 bare metal OpenShift clusters. They've got a dev, test, and a prod environment. And you can see that each one is set up identical to each other for simplicity's sake in demonstration here. And each of those is basically 3 control planes, and then we've got 5 bare metal worker nodes. So total is 24 nodes here. Now, if we go ahead and we apply hosted control planes to this scenario, we can free up resources. And so first, let's talk about that management cluster. In the scenario of the management cluster, I went ahead and I said, I'm going to create a 3-node hyper-converged OpenShift cluster. So just 3 bare metal nodes, OpenShift's running on there. It's the control plane for the management cluster, and it's also the workload location or workers for that particular management cluster. On the management cluster is where our hosted control plane control processes are going to run. And then what we can do is we can take those worker nodes that we had in the previous slide, and we can slide them into a scenario where now I've still got 5 workers for each of those environments, but I'm only using 3 physical nodes to manage all the control planes, and it frees up 6 nodes on the side. Those 6 nodes, they could be an additional cluster that you might want to deploy. Maybe you want to have dev, test, pre-prod, and prod. You could also just have extra capacity. You could take those nodes and add them to those other hosted control plane clusters. Or you could reduce that spend and not actually buy those 6 nodes. And again, this is a simplified version to show the concept here. And depending upon your environment, things could be a little bit different. But the idea here is you would save on hardware costs or even instance costs if you were doing this in AWS. The next thing is network segmenting. You don't need to have your worker nodes on the same network as the management cluster. And so in this example, our management cluster, let's say it's on VLAN 100, and maybe that's a secured VLAN that only administrators can get to, and everything is kind of locked down there. And then we've got VLAN 10 where the dev cluster is, and VLAN 20 for test, and VLAN 30 for prod. That way we've now segmented all those environments into the different networks that they need to be in. And of course, there might be different policies from security perspectives that would apply. But again, you can see you can segment that so that they're not all together in the same network space. And then there's this aspect of multi-architecture. So in this particular example, I've had the management clusters running on x86 nodes. And then maybe in my dev environment, I'm running all workers that are x86. And then maybe in test, I'm running ARM. And then you notice in prod, I got a mix of those. Because OpenShift allows us to do that, we can have that mixture of both ARM and x86 in prod. Now, this particular example doesn't make a lot of sense, because if I'm developing on x86, why am I testing on ARM? And then why am I running a mixed environment? But the example here is just to show that you can run that different combination of scenarios if you choose to do so. The other option that you can do with hosted control planes is you can actually run the management cluster in OpenShift VMs. So if you're using OpenShift virtualization, you could go ahead and spawn VMs that would then run OpenShift on top of that, and then run your management cluster in there. And then you could either run bare metal nodes like the prod scenario is running in this particular slide, or you could have your dev and test also be virtualized as well. That way, again, you can shift around and move your resources that are going to make the most sense and get the most value out of the hardware that you've purchased. And then this particular example here is to show how you could potentially reallocate nodes. So a lot of times, and think about this from maybe a retail perspective, because we all understand what retail's like. Retail has that concept of a peak season, right? So from about October to the beginning of January, they usually don't do a lot of development. They usually lock their systems down, and they usually want to scale up their particular production environments so that they can handle the capacity of all the orders and stuff coming through. In this scenario, we've got these all balanced for 5 nodes per each environment. But let's say I want to do that peak season scenario. I can go ahead now and I can remove those worker nodes from the dev environment and add them to test or to prod to increase the capacity over there. And then eventually I could go back to the reverse once my peak season is over. And the idea, or what's going on underneath the covers here, would be that with hosted control planes, you can go ahead and delete the nodes off of one of the clusters. Those nodes will then go back into this node pool concept, which is just basically a pool of resources. And then when they're back in the node pool, you can go into the multi-cluster engine, which we'll talk about here in a second. You can go back into there and you can scale up these other clusters to add those nodes that are in that free pool. So thus shifting around the resources to the most benefit and value for your business needs. So a lot of times I get people that ask me, well, what about like workloads and stuff? Well, things like, ODF running a hosted control plane, or what if my nodes have GPUs in them? Can I use the NVIDIA GPU operator? Keep in mind that the hosted control plane concept, all it is doing is taking the control plane nodes, it's taking those services and containers that run in there, and it's putting them inside of a namespace on an existing OpenShift cluster. It's not changing any behaviors on the way things function. So for example, the few examples I put up here, ODF. I have an example blog out there that shows you how you can run ODF on your worker nodes that are part of a hosted control plane cluster. It runs just the same, using the GPU operator from NVIDIA. It works just the same. If you've got GPUs in those nodes, and you install the GPU operator, it's going to go ahead and install those drivers and make those GPUs visible so that they can be consumed either by containers or by virtual machines. So there is no change to the behaviors of how OpenShift operates. It's only that the control plane nodes are no longer on a physical box or in a physical instance in one of the cloud providers. So how do I get this? So you can get this one of two ways. The first way is if you've already got OpenShift today, it's out there in Operator Hub, or if you're running version 4.20 OpenShift or later, it's called Ecosystem now, but it's already there as multi-cluster engine. You just have to go and install it and then go ahead and actually configure it. Now, if you're a Red Hat Advanced Cluster Management customer, you're going to get that automatically because ACM will install that MCE component under the covers automatically. But ACM also requires a subscription. So if you're wanting to test this out, multi-cluster engine operator is your best bet to try this today. And you could try this in a virtual environment. I've done it on KVMs. In fact, some of the screen slides you'll see are all the machines there are not bare metal. They're actually virtual machines I've used. And so here's an example of what that interface looks like. So if you go into the console on an OpenShift cluster and you've installed the multi-cluster engine host, up in the upper left-hand corner, you're going to find the drop-down will have administrators like you're used to seeing. You might have developers listed there. I didn't. And then you'll see this new addition called Fleet Management. If you click on Fleet Management, it will bring you into this UI. And I've already pre-selected here the host inventory. The host inventory is the portion where you are going to create an infrastructure environment. That infrastructure environment is where you define, where is this located? My example is Minneapolis, of course. You'll define a name for that infrastructure. You'll associate a pull secret, SSH keys, and then you'll also add hosts there that will be discovered. This is a screen where if we go into that host inventory that I created or that infrastructure environment, we can then add hosts here. And you can add hosts with a couple of different methods. You can either use the discovery ISO, and the discovery ISO is very similar if any of you have used Assisted Installer on console.redhat.com, where you basically generate an ISO, you mount it to the machine. If it's a VM, mount it there. If it's a Dell box, you go ahead and you mount it up via the BMC that way, and you boot that box. When the box boots up, it'll go ahead and it will report back into this interface. Instead of the status staying installed there, because this is already on a deployed cluster, it will say, here's a discovered host. You'll approve that discovered host. It'll become part of the node pool, and it'll be available for use when you actually go to deploy a hosted control plane cluster. Another way you can do this is with iPXE. So similar concept, you can just do, iPXE boot. You'll have to have the actual boot media available somewhere for that iPXE to pick it up. And then the other way is to use a BMC form. So again, using Dell as the example here, if I go ahead and I put in information about the DRAC and I put my credentials in, it'll be able to go out there and it'll be able to boot that node up and mount the ISO automatically. You can also use a YAML file if you've got 10, 20, 50 of these nodes to do. So you just fashion the YAML file, upload it, and then it'll go discover all those nodes. And so once you've actually got a host inventory infrastructure environment built out, the next step is to go create a cluster. Now, I want to point out, multi-cluster engine not only does hosted control planes, it can deploy OpenShift clusters, and it can deploy OpenShift clusters for a variety of platforms. And so I actually set this screen here so you could see some of the other platforms that are used for deployment. Amazon, Google, Red Hat OpenShift Virtualization, Azure, all of those are included. All the ones that you're familiar with in OpenShift documentation that are supported. But it also supports deploying a hosted control plane environment. And so here is where you would actually create that hosted control plane environment. You would click on Create Cluster. And again, this isn't a live demo, so I can't actually click on the Create. But you'd click on that. That'd open up a screen. You'd pick the infrastructure environment you wanted to do. Give it the same things you're going to give it when you're going to create an OpenShift cluster. Cluster name, domain name. Because you created the infrastructure environment with your pull secret and SSH keys and stuff, all that stuff gets populated. You pick a version of OpenShift and you go and you click a deploy. When it deploys, it's actually going to go ahead then, and on that management cluster, it's going to create a namespace based on that cluster name you gave it. And in that namespace, it's going to launch all the containers that would instantiate the control plane for an OpenShift cluster. So we haven't even touched anything related to other nodes yet. Once that control plane is up and running, then you can add the node pool to it, and you can add those physical worker nodes, or you can add your Amazon, Amazon physical instances, and that's where you get your hosted control plane cluster up and running. In this example, HCP-AD Link is actually a hosted control plane cluster that I deployed in my environment. And what it is it's basically a three-node virtual machine, and those virtual machines are actually ARM-based. But this hosted control plane cluster, the management cluster, is actually x86. So again, showing that you can have a balance of one side being, one architecture and one side being another architecture, if you choose to have that. If we click into that cluster HCP-AD Link, you can see information about it. I shrunk up the installation progress here, but if you were to expand that, you would see during the cluster deployment process, you'd actually see the steps and how it's progressing along on the deployment phase. After that, once it has deployed, you end up with this information below in the details. It tells you what kind of control plane type it is. It's a hosted control plane. It gives you the status of the cluster. It gives you the infrastructure type, which is a host inventory. Shows you the version of OpenShift that's running. You can even upgrade your OpenShift environment from here. You could click on that upgrade available, and you could start that process off, and it would go, multi-cluster engine will go off, talk to that cluster, and it will start the upgrade process automatically for you. You also get the details on your cluster API address and the console URL to access. And then, of course, your credentials. And you can also get the cube config from downloading it right here at this point. If I were to be able to click on this node section, if you clicked on that, it would show you the nodes that are already part of this cluster. Again, if you wanted to add nodes, you can increase that as well. On this page, you'd scroll down, and there would be an option there to add either node pools or add nodes to the existing node pool. So let's talk about ingress to DNS when it comes to hosted control planes. So normally when you deploy an OpenShift cluster, you're setting in your DNS, you're setting API cluster name, and you're then setting, a star.apps.cluster name. And that solves your problem for your ingress DNS information. By default, the hosted clusters are a subdomain of the management cluster. So in this example, my management cluster is appsmanagementcluster.example.com. My hosted cluster name is my cluster, or in my example, it was HCP-AD Link. My hosted cluster ingress would be apps my cluster, or apps HCP-AD Link managementcluster.example.com. That may not look very pretty, and I would agree. And so the options to make that look a little bit better are down below here. We can do things with DNS where we can customize it. So you can end up with a hosted cluster ingress like apps my cluster or apps HCP-AD Link. And you're going to do one of two things. You're going to either use a load balancer to do that, which could either be a hardware load balancer or a software load balancer, or you can use what I always call poor man's load balancer, which is basically wildcard DNS round robin. I've used both, and I find that the load balancer option is definitely the better way to go. And if you don't have a software load balancer, or you don't have a hardware load balancer, you're in luck. We can use MetalLB, which comes with OpenShift already. It's out there again in Operator Hub and in ecosystem. And this will allow you to do a self-hosted network load balancer on your OpenShift cluster. You basically install the operator and then do some configuration, and it's going to allow the creation of OpenShift services of a type load balancer for your environment. So the way that the VIPs will be announced for your API and for your ingress are one of two ways. You can either use L2 mode, which is basically just ARP broadcasts, or you can use BGP, especially if you're using that in a BGP network scenario, and that'll allow it to do BGP peering. Again, each one of these is going to require a different set of configurations. What I have found is when you do use MetalLB, you actually have to have MetalLB installed two places. You have to have MetalLB on the management cluster, and you have it there because you're going to have your API VIP for your hosted control plane cluster there on the management cluster. And then for your ingress, you have to install it on the worker nodes because your ingresses are going to run on those worker nodes. And so you need to have it there, and you need to have a bit for the ingresses to be able to answer on the different nodes that the ingress containers might be running on. So it's both locations. If you only install it on the management cluster, you'll be able to do all your OC CLI commands, and you'll be able to do anything related to the API. But if you click on the console, and try to go to the web UI, that won't show up because you're missing your ingress information and you're missing that load balanced VIP on the ingress side. So you'll need it again in both locations. So here's the list of supported platforms. So hosted clusters are supported across AWS, IBM Power, IBM Z, OpenShift virtualization, bare metal nodes. Non-bare metal agent nodes is in a technology preview, and Red Hat OpenStack platform is also in technology preview. And then you can see the versions there of where the support started from a management cluster perspective and then a hosted cluster perspective. So let's talk a little bit about hosted cluster control plane isolation. So you can get granular with this if you have to. And again, that's going to depend upon your organization's policies, especially around security and what you want shared and what you don't want shared. In the examples I was showing and the examples I've done in my lab, I've done everything shared. I don't try to, make those control planes run on specific nodes or segment them out. But if you have the requirement to have nothing shared, in your management cluster, you may add on worker nodes, and then you may taint those nodes specifically to say, only this namespace hosted cluster can run on these specific nodes, creating segmentation from other hosted control plane namespaces. Now, when I start to think about that from a granularity level, I start to think, well, wait a minute, if I'm adding more worker nodes to my management cluster, isn't that kind of defeating the purpose of using hosted control planes? And to some respects, it could be, because now you're adding additional hardware on the management cluster and you're segmenting your stuff off. So it might make more sense to just have dedicated clusters with dedicated control planes. But these are the kinds of things that you have to think about when you're considering what are you trying to accomplish, what are you trying to achieve. And maybe for a lot of development environments, hosted control planes makes more sense, but maybe for my prod run, I'm still going to have that its own dedicated control plane worker nodes setup. Or a traditional OpenShift deployment, as I would call it. And then finally, failure scenarios. So on the left-hand side, we're looking at management cluster failed components. So how does that affect my hosted control plane clusters? If a worker node dies in the management cluster, it doesn't affect the API or the ingress on the hosted cluster. If I lose an availability zone, it won't affect it. Both of those examples where I could see maybe it might affect it is if you've specifically tainted nodes to say this hosted control plane needs to run on a specific node. If that node were to go down, then yes, it wouldn't be available. But if you're thinking about this from a share everything perspective, you wouldn't be impacted. If the management cluster control plane goes down, you're still not impacted on your hosted control plane API or your ingress. The only place where a hosted control plane potentially gets impacted is if the management cluster itself, both control plane and workers, are down. Then you lose access to the API of that hosted control plane cluster. But you still have access to the data plane or the stuff that's running on the workers, because even if the API goes away in an OpenShift cluster, if you've already got scheduled workloads running on worker nodes, they'll continue to run because there's nothing for it to, to tell them kill those workloads because the API control plane portion is not responding at this moment. So that's the only failure area where you might get exposed when it comes to hosted control planes. And so finally, if you're interested in learning more about this, I put a link to the latest 421 documentation on hosted control planes. And then I've got two blogs listed here. The first one is one that I did, which actually is what some of those screenshots came from. This is a complete walkthrough of how to install hosted control planes. So I start off with basically an OpenShift cluster deployment. I turn that OpenShift cluster into a management cluster. And then I go ahead and deploy an ARM-based hosted control plane setup, and also configure the metal LB information on both the management cluster and the actual hosted cluster. So it walks you through all the steps to get this running. So it also shows verification steps along the way, so you feel confident that you're actually working towards something and not just wondering, will this work when I get to the end? And then the second blog is another one that I did a few years back. But this one shows the example of actually running ODF, OpenShift Data Foundation, on a hosted control plane cluster, if you're interested in seeing that there. And then if you're interested in the upstream project, it's called HyperShift. And I've got the link to the HyperShift docs there as well. So again, just information if you want to take a look at that. And then definitely the blogs will be helpful to understand the concepts further and dig deeper into what needs to be done for configuration. So with that, that's all I had. Do I have any questions from anybody about this? Sure.
Are there Ansible modules for managing the plane yet? I know there's stuff that with OpenShift, but I don't know if there's a specific.
That I don't know, but I can take that back and get an answer for you. But yeah, I don't know offhand with the Ansible piece. Yeah.
Any latency concerns between hosted control planes and the worker nodes?
I think that's going to be dependent upon where you're positioning those workers, right? So like if we think about an edge use case where maybe some of those workers are at a different office, you're going to run into latency because what's the bandwidth between, and the timing between that link from that remote office and where you have it. But if you're talking about something in a data center where, again, if we go back to that network segmentation example, if they're all in the same data center and they're just on different VLANs and stuff, you shouldn't really see any difference in behavior there.
No, it's more of like cloud to edge or...
Well, I would think if you were running, like let's say you want to cluster in Amazon. If you're running a thing in Amazon, you may want to run a management cluster in Amazon, but I haven't heard anybody specifically talk about that concern of latency. But again, I think it's going to be, what's the connectivity between the two things, right? That's what's really going to determine, is it problematic or not? If you've got 1.5 millisecond to 5 millisecond response times all the time, I don't think you're going to see issues with latency. It's going to become more if that link is slower sometimes, faster sometimes, it's competing for other things across that link, that's where you'll run into potential issues. Yeah?
From a subscription perspective, are the hosted control planes or management clusters, does that have to be licensed, or?
You still need to have a license for that OpenShift deployment, even though it's a hosted control plane. You don't need a license for the multi-cluster engine.
For the control plane nodes themselves, do they need subscription?
That I don't know, because I don't usually get involved with the actual monetary part of it. But we could find out.
I'm thinking you just apply your license to the hosted control plane for the worker.
Yeah, so I mean, if we go back to that example of we had 3 clusters, right? And then we put everything down to a management cluster and we merged all those clusters into that one. I think the only additional license you'd really need there was for that management cluster, right? And then you'd have the 3 licenses you originally had, which would apply to your 3 hosted control planes. But again, I think we should follow up on that just to get that licensing information for you. And Nick's going to help me make sure that we follow up on that.
One other question that might be complicated, that is any disaster recovery consideration, all this stuff at the same time.
Well, I think, so that's a good point, right? Now think about it, if it was a single node, I would think we would need to have something for disaster recovery, because if I just had a single node OpenShift management cluster and I lost it, I would lose everything from the management cluster, right? But the idea is since you are now running this on a management cluster that would be high available, just like any other OpenShift, that you're not in theory going to lose everything. But to your point, what would the backups or the restore scenario be in a disaster like that? And that's another one that I don't know. I have not heard an answer for that. So that's another follow-up item. Nick?
Yeah, you know how to find me.
Anything else? All right, well, thank you. And we're going to turn it over to Vadim.